Hello YouTubers, I'm here to talk to you guys about Hardy-Weinberg and how to use his equations and problems. So the first thing you guys should know is that when you're talking about Hardy-Weinberg, the P means the frequency of the dominant allele and the Q means the frequency of the recessive allele. So the P would normally be like the capitalized A or the capitalized B, so the dominant trait. And the Q would normally be the lowercase a, the lowercase b for the recessive allele. Okay, the next step to it is p squared. P squared is normally the frequency of the homozygous dominant, or the capitalized AA. 2pq is normally the frequency of the capitalized A, lowercase a, or the heterozygous genotype. And Q squared is the frequency of the homozygous recessive genotype, or the lowercase aa. So normally when you're talking about Hardy-Weinberg, there's only two equations you would normally use. There's normally the P plus Q equals 1, and the P squared plus 2pq plus Q squared equals 1. So I wrote out two examples to try to help you guys to understand this. So the first example is you have sampled a population in which you know that the percentage of homozygous recessive genotype lowercase aa is 36%. Using that 36, calculate the following. Okay, so the first thing you guys should do is look at it and realize that they gave you the homozygous recessive genotype, the lowercase aa, which they said was 36%. So you can automatically write it down on the paper if that's part of the question they're asking you. So in this example I gave you, I put this down as a question too. So the frequency of the AA genotype. So you already know that, so you can plug it in and put 36%. But seeing how you're going to be using a calculator, it's better to put 0.36 because it's already in decimal form. So you can just easily type into your calculator. So what you guys should notice is that the question's also asking you to find the A allele. So the thing that is, the lowercase AA genotype and the A allele, they're both similar. Because if you go back to the formula, they're both Q. And the only differences between it is that the genotype, the lowercase AA genotype, is squared, while the regular Q allele is not. So in order to figure out what the A allele is, all you have to do is square root 0.36. So the way you would do that is to write 0.36, then put it underneath the radical sign. And if you type this in the calculator, it will normally look like this. You have the sign, and then you put 0.36 inside, and you get the answer is 0.6, which I already wrote down for you guys. The next step is, if you guys realize that this is what Q is equal to. So Q is equal to 0.6. So you need to find out what the P is equal to. So all you can use the question asks you for the capitalized A allele, but we know that would mean they're asking for the P. So you know that P plus Q, so this one, P plus Q equals 1. So if you rewrite this equation and plug in the 0.6 for it, it's P plus 0.6 equals 1. So this is a normal algebra equation where all you have to do is subtract the 0.6 over, and you'll get P equals 0.4. So you know that answer. The next one is D. What D is asking for is the frequency of the capitalized AA genotype, or the homozygous dominant genotype. So the way you normally do this one is the opposite of how you did C and A. So when you did C and A, when you had C and you had to get to A, you square rooted it. And in order to get to B to D, you have to square root it. So it'll be 0.4 square root. Because remember that P and p squared are similar. The only difference is p is not squared. So in order to get p squared, you have to square p. So 0.4 squared, if you would type that into your calculator, you get 0.4, you get 0.16. So you know that the frequency of the homozygous dominant genotype is 0.16. And now for question E. This one is a little bit different, but it's still pretty simple. Because this one's asking you for the frequency of the A, capitalized A, lowercase a, or the heterozygous genotype. So if you use the formula 2PQ, all you have to do is plug in the numbers. So you know that P is 0.4, and you know that Q is 0.6. So this is a simple math equation too, because you can type the whole thing into the calculator really simply, like this. You get that this whole thing equals 0.48 if you just type into your calculator. So 0.48 would be your answer. So that means the frequency of the heterozygous genotype is 0.48. If you still don't understand it, I suggest that you go back and look at this example again. But I'm going to go ahead to the next example, and hopefully you'll understand it after this one. Okay, so in this example, they're asking you, within a population of butterflies, the color brown B is dominant over the color white, lowercase b, and 40% of all butterflies are white. Calculate the following. So the first thing you should know is that they told you that the color white is dominant. So the color white is recessive. So you can put an R for recessive to help you remember that when you're looking at it. So color white is recessive, and we know that 40% of all the butterflies are white. So you easily can know that the frequency of the lowercase aa genotype is 40%, or 0.4, because you have to type into a calculator, so this will be easier for you. So like we did in the old equation, in order to get from q squared, because we know that this is q squared, to q, you have to unsquare or ratify it. So you type 0.4 into your calculator and ratify it. So this would be 0.632455 So you can easily round that to 0.63. So the next question is the frequency of the capitalized A allele, or the homozygous dominant allele. So you can use the same formula, this one, P plus Q equal 1. So if we set it up, you know P plus Q equals 1. So you can plug in the 0.63 in. And then it's a simple algebra equation like before. So you subtract the 0.63 over, and you get P equals 0.37. Okay, so the next step is C. We already know C, so we can skip that one. So you go to D, the frequency of the homozygous dominant genotype. So the way you figure this one out is, if you remember from up top, the frequency of the homozygous dominant gene is just P squared. So we know in this one, P is 0.37. So if we square 0.37, you have your answer for the homozygous dominant genotype. So if you type into your calculator 0.37 0.37 squared will equal 0.1369. So that'll be your answer, 0.1369. Normally you don't have to write out the whole answer. You could have rounded it to 0.13, but I wrote it out to be easier, to give a more accurate number. So now it's time for the last one. This one is they're asking you for the frequency of the heterozygous genotype, which we know the equation for this is 2pq. So all you have to do now is plug in the numbers for it. So you keep the 2 and you plug in p is right here. I mean, not that one. P is right here as 0.37. And Q is 0.63. So all you have to do is you can type into your calculator and it'll give you the exact answer. So 2 and you get your answer for the frequency of the AA genotype is 0.4662, or you can round it to 0.47. And that is how you do Hardy-Weinberg. I hope this helped.